Hello, my name is Devin, and this is Modest 1.0. In this video, I will be going into the collision that the engine offers. So the precursor to this is the scenes where I mildly touch it. Helpful to go back and watch that, though. Anyway, so we can set collision pairs, we can set collision to self, and we can set collision to the terrain. I will get into the terrain later, but for now, we're going to focus on just the three volumes that we offer. Oriented bounding boxes, axis line bounding boxes, and bounding spheres. Now, we do also offer line casting, but I have not demoed in this, so I won't touch on it too much. Anyway, we have, as I said, ABBs, OBBs, and B-spheres. This is how we set a collider this is how we actually set it up for collision. In the scene, we have to register it for actually collision testing, so setting the collision pair, player tank, and the tree. We have to do that in every scene that we have. So next up, basically, once we initialize or construct the object, it doesn't necessarily matter, but we can get the model from the object. In this case, I have tank parts, so I got a body, a turret, and a barrel. So I'm getting the model from the body, which is just a graphics object offered by this library we're using called Azul, which offers all of our math and everything. So this is a graphics object texture light, taking in a model, a shader, and a texture, as well as a color and a light position. Light color and light position. That's basically how that's working. Anyway, so we get the model from that, set its collision volume that we want. We set the collidable group, player tank, and then we submit it for collision registration. Setting that collidable group is actually how we match it against other objects. And submitting it for registration, that means it wants to collide, and it can collide. Now, that means it'll be run through the dispatch, through the commands that are created for collision. So I will get into showing exactly how this all works. I said I could actually visualize all the collision, and I will turn down the volume real quick just so I can actually... There we go. All right, no volume at all. So collision is visualized. There is tiered collision testing to a degree. So every object has a default bounding sphere. We can set the collision volume. I put B spheres on the tanks specifically for playability of the game, but these trees actually have oriented bounding boxes. There is also group AABBs. So, you know, this big yellow line across the sky, that's actually the trees. The group AABB for the trees. So if there's an object group that's colliding with another object's group, so the player is colliding with the trees, it will show up yellow right here. It's colliding with the trees. Now, it's not colliding with these enemies. Now it is. That's the enemy's AABB. Bullets right here. See those. And then there's the default B-spheres. So once it's in the default B-sphere, then it will test to see if it collides with the OBB. Now it has. And meanwhile, all the collision testing is done by the exact object. That's because, you know, ABBs against B-spheres as well, those are cheaper than actually testing for OBB collision every frame too. So as we see here, B-sphere, OBB collision. Now that that's demoed, quit to menu as well. I don't think I demoed that in the game. Anyway, so basically what I have to show here is the collision system. Now we have to actually inherit from a certain... We have to inherit in a certain way. So the tank base, as I showed earlier, is collidable. Collidable is the base derived from game object over here. Anyway, so we offer this terrain collision. We offer collision with another collidable as well. Submitting for collision registration. These are the commands that we actually set. Setting the collider model. This is the important one. So we give it the model and the volume type. It sets the model, gives it a default bounding sphere, creates the collision volume. As I said, line casting is in here as well. And gives it the model as well, depending on the thing. Then we update collision data. This is actually important. So this has to be called an update. Or it can't be called a collision or anything, because otherwise it doesn't work. It has to be called on the object's update. So if an object is, or, you know, initialized, if it's just a static object, you know, static is in place. That being said, so if this isn't called, then the collision data will not be set correctly, and it will likely not collide because the data will be set to 0, 0, 0, even the matrices as well, because that updates the world position and everything. Just an important note. Back to the collidable now. So we compute its data and we compute the model and everything, and that runs through a math tools, which actually tests for intersection and everything. It basically computes the data. I'll actually run it into one of these. I don't know why I'm not. So this collision volume, it's a base class, and then there's multiple other ones. So B-sphere, line cast, ABB, OBB, and other volume. So this is how it's using visitor pattern. It actually tests for collision against these other objects. So if we go to game object management, collision, and here are all the volumes. Here's the AABB, for instance, and we have these visits against other ones. So we go into here, and it checks for intersections. And that's basically how this is done. Computing data, also done based on, actually getting it called. And then now I'm going to actually show how those commands are called. So we have a couple commands. We have test terrain, test self, and test pair. So, and the test base. So we run through the test pair command, and that has a couple things. It has dispatch and the 2 collidable groups. So it runs through those collidable groups, the collections of their collidables, and it executes this command. This is done through the scene. So it runs tiered tests. It gets it, if it's the group AABB versus the ABB, then it will run into the AABB versus an object's B-sphere. If it's colliding with that, then it tests 2 objects' B-spheres, default B-spheres against each other. And if that goes through, then it actually tests the volumes much faster than doing, just OEBs, AABBs. Anyway, so that's the test pair. Test self is pretty much the same. Now, the test terrain I'm actually going to get into later, but we use an iterator for that. And basically, the terrain, I'll give a quick overview. The terrain is basically set up as a bunch of AABBs. So you might have seen actually in the video a bit of terrain collision. So right here, as you can see, this is the object's B-sphere colliding with the terrain. And the red squares are the ones that it's not colliding with. The blue squares are the ones that it is colliding with. And you can see they're just axis-aligned bounding boxes. Anyway, that is pretty much a rundown of collision. I forgot to actually go into the dispatch as well. So there is a dispatch base, and there's process callbacks for both the terrain and the standard objects. Now, that is set originally. The collidable groups and the dispatches are both set through the collision manager. So if we go into the managers and we go into the collision manager, we have the ability to actually set them. They're templated functions. Actually getting the group ID, setting the collidable groups, same thing with the terrain, and self-testing. All right. Now that pretty much is a rundown of how collision works, and to save time, I will move on.